I wanted to talk a little bit about some of the bad elements of PEMDAS. Um, it's a convention that's 6 letters, parentheses, exponents, multiplication, division, addition, subtraction. But often what happens is people will assume that it's a 6-step um, thing when it's really only 4. And first, I'm going to say PEMDAS and the order of operations is not incorrect. It's not wrong. But what's really wrong is our understanding of the relationship between multiplication, division, addition, and subtraction. A lot of people went through a memorization process of PEMDAS where they memorized the 6 letters. But sometimes I like to just, draw them vertically where you've got the parentheses, exponents, then you have multiplication, division, addition, subtraction on the same level. Where you see the MD or the DM, either way, you're really looking at the problem and looking to see if multiplication or division comes first, and you solve them in the order that you find them. The same's true with addition and subtraction. Now, the relationship between multiplication and division is one that a lot of people don't think about. People will memorize PEMDAS and they'll think, well, multiplication comes first because the M comes before the D when you memorize the 6 letters. But what they're not really understanding is that division is just multiplying by a reciprocal. You can take 10 divided by 5, which equals 2, or I can say 10 times 1/5, which equals 2. They're just the same thing. Division is just really multiplying by a reciprocal, so you can think of them as the same operation. Now with addition, you have, you can take that and you can take 6 plus 2 equals 8. Then you can reverse it and say 2 plus 6 equals 8. Now, with subtraction, you can't do that. 6 minus 2 is 4, but 2 minus 6 is -4. All right, so, and now the relationship between addition and subtraction. The relationship between addition and subtraction, you could take 6 minus 2 equals 4, but think of subtraction as just adding a negative number. So 6 plus minus 2 is also 4. So it's really the same operation again. So addition and subtraction also have equal precedence. Now, when you think about multiplication, you need to think of multiplication as just repeated addition. It's like a shorthand for addition. So 5 times 4 would be the same thing as adding up 5 fours, and it's equal to 20. Um, Also, you could write it out like, 4 fives, right? 4 times 5 would be adding 5 or adding 4 fives. 5 plus 5 plus 5 plus 5. That equals 20 also. So all of these are correct. You can do the multiplication, which saves you a lot of time writing or typing, or you can do the addition. Now, for multiplication also has an associative property, which just means that you can arrange the numbers in the multiplication any way you want, and you're going to still get the same answer. So, for example, I can take 3 times 2 times 5, which is 30, or I can rearrange it as 5 times 2 times 3. That's also 30, or 2 times 3 times 5 is 30. Now, the associative property doesn't apply to division, kind of like what we showed on subtraction. If I take 6 divided by 2, well, that's equal to 3, but 2 divided by 6 is 1/3, so that doesn't work. And then here's an example. This is a problem that's been going around online a lot. 3 plus 3 times 3 plus 3 equals. Now, a lot of people will say you just go left to right to solve that, but that would be incorrect. You can take the multiplication that was in the middle and you can actually put that in the front. You are allowed to rearrange that. You can make it 3 times 3 plus 3 plus 3. And for the people who like to solve left and right and not follow the order of operations, you're going to get the answer of 15 because you're going to get 9 plus 3 equals 15. And then you're going to get that. And then um, the other thing to look at here is if you're just solving these problems left to right and ignoring the order of operations, what's going to happen is you're going to go 3 plus 3 is 6. Then you're going to times that by 3, which is going to give you 18. Then you're going to take 18 plus 3 and you're going to get 21. You're going to get 21 dollars. So, think of it like, you were selling iced teas at a lemonade, or you're selling lemonade at the lemonade stand, and you're charging $3 a glass, which I guess is like a, post-COVID price. But, on Monday you sold one for $3. On Tuesday you sold three at $3 a piece, and then on Wednesday you sold another one cup of lemonade for $3. And so that could represent, the reason you got the multiplication in the middle is it could just mean that, hey, on Tuesday you sold three of them, and you're writing them out in, per the day of the week. Um, so, this math doesn't work out. If you think of that as like the lemonade stand, you should have made $15, not $21. So the other thing you can do is you can take that multiplication, like we talked about before. Multiplication is just repeated addition, right? So you can take the 3 times 3 and make that 3 plus 3 plus 3. So you're going to end up with 1, 2, 3, 4, 5 threes that you're adding together, and that gives you 15. So there's another way to solve it, where you're recognizing I've got to deal with this multiplication first. You can either take 3 times 3 or just convert it over to addition like we did there. So when you look at it, 3 plus 3 times 3 plus 3 is 15. 3 times 3 plus 3 plus 3 is also 15. Because if you go back to that lemonade stand example, it doesn't matter if I sold the 3 lemonades on Tuesday or if I sold the 3 lemonades on Monday, as long as, in this example, they sold 5 total lemonade, cups of lemonade from Monday, Tuesday, and Wednesday. So it doesn't matter what order you sold them in. You could have sold all 5 of them on Monday, I guess, and that would have been, say, 5 times 3 is 15, right? And then you didn't sell any on Tuesday and none on Wednesday. So, you have to think about sometimes these expressions are used to represent, real world examples. So, you really should be getting the same answer. And as you can see here, you do. Now, as far as how the order of operation works, it's number one, parentheses, number two, exponents. Now, remember, sometimes parentheses are called brackets. In other English-speaking countries, they don't refer to the word parentheses very much. Exponents sometimes are called indices or orders, depending on where you live. Then it's multiplication and division left to right. Sometimes I've written this multiplication or division left to right, and people will misinterpret what I'm saying. What I'm saying is, when you're going left to right, you solve multiplication or division based on which one you run into first, going left to right. And then basically you get down to the bottom here and you've got addition and subtraction left to right. So again, you would just solve them left to right after you've finished with multiplication and division. Now, one big point to remember, if there are no parentheses or exponents, you would start with multiplication or division, solving left to right. And then lastly, solve your addition and subtraction left to right. So just because you don't have parentheses or brackets, you don't ignore the order of operations. You keep going down through the list. So again, 3 plus 3 times 3 plus 3. We solved, for following the order of operations convention, you solve the multiplication first. 3 times 3 is 9. Then we're going to add. We don't have any subtraction, so it's 3 plus 9 plus 3 equals 15. Now, I don't know how much I really want to get into this one, but what about a problem like this? This one's been really viral. There's been tons of videos, some of them made by PhDs in mathematics, so I'm not going to really spend a lot of time on this one, other than to say, take a look at this for yourself. But 6 divided by 2 times the quantity 1 plus 2 equals what? Well, the first part's pretty simple. We see the division sign, so we know we have 6 divided by 2. Then we have parentheses with a 2 outside of it. Now, the convention there, the assumption is that we're multiplying whenever you have a number next to the parentheses. So we're assuming that outside the parentheses we're multiplying. And then, of course, you've got the stuff inside the parentheses that we have to take care of first, the 1 plus 2. If you're looking at this through order of operations, you would go, you could take 6 divided by 2, which is 3. You could also convert that to 6 times a half, right? Because, division and multiplication are related to each other by a reciprocal. So 6 times a half times 3. You're going to end up with 3 times 3 is 9. So, the big argument online is a lot of people are saying it's 9, because they're following order of operations or PEMDAS or BODMAS, whatever. And then some people are claiming 1. Um, and we'll get to that in a second. But, when I solve it on my Android cell phone calculator, it tells me it's 9. If I go to Wolfram Alpha, it'll say 9. Now, when I entered it in at Wolfram Alpha, it wants to make a fraction 6 over 2 times 1 plus 2 in parentheses. It also gives me 9. I have a Simbo app on my phone that can do these problems, and it's following just, your standard order of operations and giving me 9. And so, one thing you could say is, why not just write it as 6 divided by 2 with a multiplication symbol and then 1 plus 2 equals to avoid, the so-called controversy that's out there. I mean, I don't really necessarily want to get into it. I mean, there is this thing, and I don't know the background of it, the real true history. I've seen some videos where they claim like, there was an older interpretation prior to 1917. I don't know if that's accurate or not. I'm just going by a video that I saw. So I haven't done the research myself, so I'm not going to comment a lot. But apparently there was an older interpretation where the number outside of the parentheses was considered multiplication by juxtaposition or implied multiplication, and it's given a little higher priority than your normal multiplication or division. Basically, in one video they refer to something called Pem Pejmenda. I can't even say it, but it's Pejmdas, where J would be your multiplication by juxtaposition. Now, um, I know that like in the modern interpretations aren't really considering that and using that. Really the stricter interpretations don't give that hierarchy. It's really confusing though because I've actually seen some of the manuals. There's a video out there. I think that's the How and Why of Mathematics. I need to get that link again and post it in the notes. But she actually pulled up some manuals from some different Casio calculators, possibly even some TIs. Or even in the manual, they talk about multiplication by juxtaposition, and they even show the hierarchy where they will solve it. So you could run into a situation depending on when your calculator was made. I don't think these calculators were all that old. Not more than a decade or two at the most. I'm not sure, but some followed this multiplication by juxtaposition and others don't. So you could possibly run into a scientific calculator that will give you a 1 instead of a 9. So yeah, I mean, I don't know. Most of the problems that I'm going to be dealing with on here, I'm not really going to deal with any of that. I'm going to stick using the operators just to avoid some of the you know controversy. And anyway, I rarely recommend saying just type it into a calculator because you run into issues where some people either don't know how to use a calculator correctly, and I've seen people enter, whenever you have a long expression with multiple operations, they'll actually hit the equal sign after every operation, which isn't correct. And I don't know why they do that. I guess they just don't understand how to use a calculator properly. And I also see situations where people will use a cheap dollar store calculator, or maybe the standard calculator off of the Windows computer, where those don't have what's called an internal stack of memory, where they can actually keep track of the multiple operations. A normal scientific calculator will keep track of multiple operations and you'll get the right answer. Kind of like, what I showed on on the Android phone, I know that that's already set up for order of operations correctly. So a lot of people will use this cheap calculator and they'll automatically assume, well, see, you just solve everything left to right. My calculator told me so. So I see a lot of people online where they'll say, just type it into a calculator and then tell me what you get. Well, you got to be careful when you say that because first of all, you don't know if that person knows how to use a calculator correctly. You don't know if they're using the right calculator. They could be using a really cheap one that can only do one operation, and so not always the best recommendation. But again, I want to just say that the Math Puzzle Crash Course is on YouTube, so you can look it up. It's a relatively new channel. It's I guess that's maybe growing a little bit. I'm not very good with the editing on it so far, so I do apologize. It's very much a budget thing. Just using the audio off of my laptop microphone, which I understand is not the best, and my laptop camera, and just really using Bandicam and some PowerPoint to create some slides, no fancy graphics, anything like that at this point. So I'm really just kind of doing this to pass on the information because, I'm seeing some really, really bad mathematics knowledge out there, some really bad myths that are getting spread. This whole thing about, order of operations doesn't apply, if there are no parentheses or brackets, which is totally false. And then also a lot of people are imagining they were taught, left to right back in their day. And like, I don't know why some people believe that. I mean, I don't see how any competent mathematics teacher would ever have taught that. I do know that PEMDAS, a lot of times it's taught like a rote memorization type drill, or people will learn things like, please excuse my dear Aunt Sally, and they just get those 6 letters stuck in their head too, and it leads them to start believing things like, well, it's PEMDAS, it's not EMDAS, and it's not MDOS, it's not DOS. It has to be PEMDAS or it doesn't work, which is totally false too. A lot of people will say no parentheses, well, you just go left to right. Or some people will say, well, multiplication comes before division because the M comes before D when type out PEMDAS. And that's not true either. But anyhow, enough on all this stuff. I just wanted to say, the channel is on YouTube. I do appreciate, any likes, any, subscriptions if you do like any of the content and want to subscribe. I am really at this point trying to stick with some of the basic mathematics problems. I'm steering away from some of the controversial stuff between, this juxtaposition and order of operations. I do understand both sides of it, and I know there's some controversy, and I do know a lot of people butt heads on that issue. And my focus really is on the simpler problems where you have clear operations. There's no consideration for ambiguity. There's no ambiguous math in anything that I want to concentrate on. And and I get a lot of people will say, well, even if you don't have the multiplication operator, there's still no ambiguity. And I guess not if you're following, the strict order of operations. But I mean, there are some mathematics journals out there and textbooks from the past, and we've even run into these calculators. I would say what I think there was a Mind Your Decisions channel has a video. The How and Why of Mathematics channel. I can't remember her name, but she went into some detail with some calculators and reviewing those and why they get different answers. But and there's some others out there, but my focus is on the simpler stuff. I'm trying to stay out of the controversy. I'm more interested in the fate controversy of solving left to right versus following order of operations. There's a lot of people that believe that you just solve left to right, and I'm trying to get them to understand that that doesn't make sense because, like in the example of the lemonade stand, I should be able to swap my multiplication and put it in the front or, do things like that. And you should always get the same answer, right? If we're representing some real world activity. So yeah. Anyhow, enough of that, and hopefully this has been helpful. Please like, subscribe, and share. Thank you.